Everyone, so today's problem of the day is search in rotated sorted array. And what is given in description? There is an integer array nums sorted in an ascending order with distinct values. That means values are not repeated. Prior to being passed to your function, nums is possibly left rotated at an unknown index k, where key is lying from 1 till nums dot length less than nums dot length, such that the resulting array is nums k comma nums k plus 1. That's and that is left rotated means now our array is starting from kth index, and it is 0 indexed. For example, 0, 1, 2, 4, 5, 6, 7 is the array, might be left rotated by 3 indices. If it is rotated by 3 indices, that means the third index. The array is starting from the third index, 0, 1, 2, 3. So it will start from fourth index, and this 0, 1, 2 will go back. Now, given the array nums after the possible rotation and integer array target, return the index of the target if it is in nums, or a -1 if it is not in nums. I mean to write the algorithm in big of log and runtime complexity. So if we will see for the first example to understand better. This is rotated sorted array. That means initially it will be something like 0, 1, 2, 4, 5, 6, 7. We rotated it so these three elements from the starting move to the end. And now we need to search, and after rotating, array is looking something like this. And we need to find if 0 is there in the array or not. So if we will see 0 is there, and we need to find the index. So this is 0 is at fourth index, so we can return 4. And if we will see for the second example, they are looking for 3. So if 3 is there, we need to return the index, and if it is not there, we can return -1. So if we will see for the constraint it is given nums dot length start from 1 till 5 into 10 to the power 3. 5000 means 5 into 10 to the power 3. That means if we will try to write this solution in big of and time complexity, we are able to it will easily accept our solution. But in our question, if it is given that we need to find write in big of log and time complexity. So if we will see for the brute force approach that will take big of and time complexity, we can basically use one for loop, and we can check for every index if that nums of I is equals to target, then we can easily return that ith index. And at the end of this for loop, if we are not able to find, we can basically return um, -1. So this is the brute force approach, which will take big of and time complexity. But in our question, it is given कि we need to write some solution in big of log and time complexity. And if you will see the question, we will be giving rotated sorted array. Rotated sorted array means the array is sorted, but it got rotated. So if something is coming related to rotated, we can think of using the binary search. And we all know that time complexity, if we will check for the time complexity for binary search, it will be big of log n. And we need to find solution in big of log n only. So how we can do it with the help of binary search? Because this is rotated, so we can't apply binary search directly. If it is something like 0, 1, 2, 3, 4, 5, 6, 7, and we have to find 0, then we can easily apply, we can start, this is my lowest pointer and this is my highest pointer, and I can basically find mid, which is equals to L plus H by 2. And if my nums of mid is greater than target, then I can move left. Otherwise, I can move right. This is the basic binary search. But in our question, it is rotated. So we can't apply binary search easily. We need to write some condition to before applying the binary search. So what we can do in binary search, this is like generally we will be using two pointer, left pointer and the right pointer, and we need to find the mid. So this will be same in our case also. We can this will be a left pointer, 0th index, and last index. Will be a right pointer. Now, if we will try to find mid, how we can find mid? L plus R by 2. If I'm trying to find mid will be something here at this fourth index. And how I can see for key and first of all I need to check if my nums of mid is equals to target or not. So target is 0 and my nums of mid will be 7. So it is not equals to this target. So we need to either move right or left for the binary search to run in big of log and time complexity. We need to move either left or right. But how we can check if we need to move left or right? So so how we can check in this case? We need to see ki, if we will see for this left side, ki, if some suppose my this mid, my nums of mid that is at that is 7 is greater than my nums of left that is 4. If my nums of mid is greater than nums of 4, that means मैं अगर मेरा ये वाला इंडेक्स इस पे जो वैल्यू है अगर वो ज्यादा है ये वाले लोवेस्ट इंडेक्स पे, दैट मीन्स कि मेरा ये लेफ्ट साइड है वो शॉर्टेड है. सेम फॉर द राइट साइड कि अगर मेरा जो राइट इंडेक्स पे जो वैल्यू है अगर वो बड़ी है जो मेरी मिड पे जो वैल्यू है, देन वी कैन से कि राइट साइड इज शॉर्टेड. So if we will see in this case, a left side is shorted. So if we got to know कि left side is shorted. Now what we can check, if it is shorted, we can check कि target is there or not. Because in shorted we can easily check, like we can check using कि if this target is greater than equals to our nums of left and less than equals to nums of mid. If this is the case, if something our this target is greater than equals to nums of left and it is less than equals to nums of mid and it is sorted also and it is greater than this and less than this, that means we can say it is lying in the right side, sorry, in the left side. But in our case, if we will see our target is 0, which is not lying in this range because it is not greater than 4. It is less than 7 is fine, but it is not greater than 4. That means it will not be in this left side. So we can easily say कि we need to move to right side. If we need to move to right side, then my lowest will change. My lowest will be mid plus 1. So my lowest is this, and my right will be same only. Now again I can check for mid. So this will be my mid, and I can check that this left side is shorted or not. So how I can check if this left side is shorted or not? If my that if my this mid, the value at mid should be greater than my value at lowest, which is true. 1 is greater than 0. That means this side is shorted. So if this side is shorted, we can check कि this 0 is lying in this side or not. So if we will see कि 0 is greater than our left pointer and it is less than equals to our mid pointer. It is greater than equals to our left pointer and it is less than equals to our mid pointer. So we can say कि this 0 is lying in this range only. If it is lying in this range, then what this is our left now, and now this is our mid. So now mid will be equals to sorry, my right will be equals to mid minus 1. So my right will also point to this zeroth value only. Now again we will check, okay, this is my left and this is my right also. Now we will check, we will try to find mid. So mid will also be pointing here only. So then I can check my 0 is the value at this index is 0 or not. So this at this mid my value is 0, so I can basically return mid. So I can basically return 4. Same thing we will do for this. So we need to find 3. So how we can, our left pointer initially is here, our right pointer is here, and we can find mid will be somewhere here. Then we can check key if left is shorted or not. So left is shorted, but 3 is not lying in this left. That means we need to move right. If we will need to move right, so my now left is changed to this, my right is same only, and mid will be somewhere here. Now I can check my any one side. If I am checking for the left side, it is shorted or not. So this is shorted only because my mid value is greater than equals to my left value. So if it's shorted, then I can see if my 3 is lying in this or not. So my 3 is not lying. because 3 is greater than, it should be less than mid, but my 3 is greater than mid value is 1. So I can basically move to this right side. So I move to this right. So now my left is this and right is also pointing to this same index. And if I will be trying to find mid will also point to same index. But if we will see uh, for the value, if that value is equals to target or not, it is not equals to target, so we can basically return -1 because there are no further index left. So the same thing I have done in the code. I initialize my length in time and then left pointer, and this is like lowest pointer and highest pointer. I represented right pointer with the H. This is basically the highest pointer and lowest pointer. So I need to run while loops in till my left pointer should be less than equals to my uh, highest pointer. My lowest pointer should be less than equals to my highest pointer. Then I can find the mid. Then after finding mid, I will check if this value at mid is equals to target or not. If it is equals to target, I can basically return mid only. If not, I can check if my nums of h greater than equals to nums of mid. This what this line is saying. Ki my this right pointer is greater than equals to my mid. That means if it is true, then this our right side is shorted. If our right side is shorted, then what we can check? We can check if our target is greater than equals to mid or less than equals to edge. If it is lying, our target is lying in this range or not. If it is lying in this range, then we can change our left pointer to mid +1, and if it is not lying, then we can go with we can change our right pointer to mid -1. We can jump to this side. The same thing if it is not shorted, that means this side will be shorted. In else condition, that means this left side is shorted. If left side is shorted, then we can again check the same thing. Ki my this number is lying in is basically lying in this range or not. If it is lying in this range, then I can basically do h equals to mid -1, and uh, I can switch to left side. And if it is not, then I can do L equals to mid +1, and I can switch to right side. At the end, I can return -1. If we will see time complexity in this case, it will be big of log n, and space complexity will be big of 1 only because we have not used any express. So yeah, thank you.